Hey everybody, we're going to be taking notes on the 7th grade Common Core lessons 3.3 and 3.4. We're going to be solving one-step equations, but we're going to be doing so using algebra. It's very important that all of your work is shown using algebra. That's great if you can do it in your head, but that's not going to cut it. Neither is modeling. So the 5 examples that we're going to work through are all using algebra, and steps are very important. So please make sure that you're starting and stopping your video and write down exactly what I've written down. By the end of the video, your notes should look the exact same as mine. All right, so in order to solve all these problems, your goal when solving an equation is to isolate the variable. In order to figure out what you're going to do in order to solve that variable, to solve for the variable, you need to ask yourself what's happening on that side of the equation with the already existing variable. So let's talk about in number 1. In number 1, I want to go ahead, and sometimes I do this to help me out visually, and I say, all right, what is on the same side as the x? Well, it's a -5, because I'm going to go ahead and do this. Write an equivalent addition expression, all right? So I have an x, I have a -5 is being added to the x. All right, and on this equation, all right, I'm going to go ahead and ask myself, all right, what's happening on this side? Well, 8.2 is being added to x. On this equation, x is being multiplied by -3. On this equation, x is being divided by 10. And on this equation, x is being multiplied by -1/2. So once you've identified what to do, you need to figure out what to do to get the variable all alone. So in the first example, x is being added to -5. So how do I get rid of -5? I add 5 positives. So on both sides, I am going to add 5 positives. A -5 and a +5, those are 5 zero pairs, so that equals 0. So I'm just left with x on the left side of the equation. -3 plus 5 is +2. So x is equal to -2. And I can plug that back into the equation to check. X is equal to 2. Is 2 plus -5 -3? It is. So I've now done the equation and I've solved it correctly. In example 2, we've already identified that 8.2 is being added to x. Well, how do I get rid of the 8.2? I go ahead and I add 8.2 negatives, or -8.2. So I'm going to add -8.2 to both sides, creating 0 pairs. 8.2 plus -8.2 ends up equaling 0, and x is now by itself. Now, this part right here, I have 4 plus 8.2, and 4 plus -8.2. I have a positive and a negative. I have to go ahead and I have to subtract because I have 0 pairs. And when I do so, I write what number I have the most of on the top. And I may have to go ahead and do it to the side or take a time out. So up here, I need to do 8.2 minus 4.0. I'm lining up the decimal points. I know my answer is a negative because I have more negatives. My answer ends up being -4.2. I can go ahead and plug that equation, plug that value back into the original equation to see if it worked. Is -4.2 plus 8.2 equal to 4? Well, it is, so now I know I've done the problem correctly. In the first two, something was being added to x, and therefore I added the opposite. In this case, I added 5. In this case, I added -8.2. And in both, I went back and checked it. In example 3, I knew that I was multiplying x by -3. Well, the opposite of multiplying, or how I'm going to get rid of a multiplying by -3, is dividing by -3. And I want you to write that using a fraction. So we're going to demonstrate division by a fraction. So I'm going to divide both sides by -3. -3x divided by -3 equals 1x, or now x, because we don't write the 1 in front. 12 divided by -3 is 4. So if I were to plug in -3 times -4 equals 12, so I know I've done the problem correctly. In example 4, I've identified that x is being divided by 10. Well, what's the opposite of dividing by 10? That's multiplying by 10. So I'm going to multiply by 10 on both sides of the equation. And I'm going to do so by writing a dot or a parentheses and multiplying at both sides by 10. Not underneath, simply next to it like I've done. 10 times x divided by 10 is x. So now I've just isolated the variable. Negative 4 times 10 is negative 40. I plug in to my equation that negative 40 divided by 10 is equal to negative 4. So I know I've solved the equation correctly. The last question, the last example is the most difficult because I need to identify that negative 1/2 is being multiplied by x. Well, what's the opposite of multiplying by negative 1/2? That's dividing by negative 1/2. But you need to take it one step further. When you divide by a fraction, you truly multiply by the reciprocal. So rather than writing the division sign and dividing by negative 1/2, I'm going to multiply by negative 2. All right, this example 5 is going to get in my way, so I'm going to rewrite it over here. All right, so I need to divide both sides by negative 1/2. Dividing by negative 1/2 is the same as multiplying by negative 2. So I'm going to multiply by negative 2. Negative 2 times negative 1/2 equals x, or 1x. So now I've just isolated the variable. Negative 4 times negative 2 is positive 8. So 8 ends up being the answer to the equation because negative 1/2 times 8 is negative 4. Let's go back and talk about that at last example. I've identified that negative 1/2 is being multiplied by x. The opposite of multiplying by negative 1/2 would be dividing by negative 1/2. But when I divide by a fraction, I multiply by the reciprocal. So negative 1/2 times negative 2 equaled x. Now, anytime you're solving for an equation, your goal is to isolate the variable and find what the variable could equal in order to make the statement true. So each time you solve for an equation, you need to go back and make sure your equation is correct. Please make sure your paper looks identical to my paper, except for the couple scribbles. Make sure that when you're dividing, it's underneath. Make sure it's multiplying, it's next to. And make sure when you're adding and subtracting, it's underneath. Thanks, guys. Have a good one.